Welcome back. In this video, we are going to be addressing the properties and rules of integrals. We're still not going to evaluate by hand or algebraically, but we need to go over some properties before we do that. So I want to get started with this. I gave you this printout, but I want to start with another property that's just kind of good to know. If you take the integral from a to b of a constant function, so c means a number. So for instance, if you took the integral, say from 0 to 4 of like 3, the function 3 dx, it's going to work out the same every single time. If you graph the function y equals 3, and we cut it off at 0 and at 4, what we've basically done is created a rectangle. And so the area under that graph is always going to be the width of the interval times the height or the function. So to write that down, the integral from a to b of c dx, let me kind of move this out of the way so you can see a little bit better. It's going to equal the width of the interval times c, or c, the constant, times the width of the interval, which is b minus a. So in the example that I gave you earlier, the way you would evaluate this is basically take the value 3 and multiply it by the width of the interval. And of course the answer is 12. So that works for constant functions. That's an easy way to calculate them. Now, the rules of integrals, we have here, first of all, the order of integration. If you notice, if we go from b to a, if we switch that order, your answer is going to be the same, but it's going to be the opposite. And we kind of know that already because if you switch directions, it's going to change the sign of your answer. So sometimes the answer is going to be positive and it will go to negative. Sometimes it would be negative and go to positive. Let me kind of show you what that means. Let's say that we take the integral from 2 to 7 of some function we don't know, and we let that equal 3. Or we are told that it is 3. If you were to reverse this and say the integral from 7 to 2, if you reverse it, you must then change the sign of the answer, so it would be negative 3. If it were negative 3 to begin with, then it becomes positive. So basically it becomes the opposite of what the area used to be, or the answer used to be. So that's what that one means. You guys probably already intuitively saw the second one, where if you take the integral from a to a, which means the boundary isn't changing, so you're not really moving anywhere, the answer is going to be 0. The constant multiple is saying that if you take the integral of a function and multiply it by a constant, you can take that constant out and just do the integral of the function and then multiply it by that constant. And the same thing happens with a negative. Sum and difference, if you take the integral of two functions that are add or subtracted, you can take the integral individually of each piece and then add or subtract those areas. And the additivity might need a little more explanation. The integral from a to b of your function plus the integral from b to c of the function is the same as the integral from a to c. So basically, if you take the integral from a to b, this area right here, and then you take the integral from b to c, this area right here, it's equivalent to taking the integral from the area A, all the way to C. That one's a kind of a common sense rule. The next two we don't use as much, but just to explain them, what they mean is the following. The true area under the curve is going to be between, at the lower end, the minimum value times the width of the interval, and at the higher end, the max value times the width of the interval. What that basically means is that if you go to your function and you have a min value, so for example, that would happen here, if you multiply that min value by the width of the interval, it basically creates the rectangle that you see here. And if you find that area, that's going to be the bottom half. So if you take the min value and multiply by the width interval, you get this rectangle. Now, if I go to the opposite and take the max value, so that would be here, and if I multiply by the width integral, I basically create a rectangle that is this big. And you can see that that's going to be more, when I color it in, that area is going to be more than the true area under the blue curve. So this property is basically telling you that your real answer is between this red rectangle and this green rectangle. It doesn't really tell you what it is, it just tells you the answer is in between. And the last one is kind of just very intuitive. It just says that if you have a function that is bigger than another function, so in this case x is bigger, it has higher y values than g, then the integral of the higher function is always going to be bigger than the integral of the lower function. And that's basically the properties. What I'm going to do now is give you some examples that are going to look like your assignment so you can practice, and they're going to focus more on the first 5 rules, not necessarily 6 and 7. Okay, so what I have set up here is a problem, much like AP is going to give you. Here's some information about some integrals, and you don't necessarily know what those functions look like or what they are, but this is the given information, and then you're asked to evaluate what's down here. So we'll take the first one. It says to evaluate 5 times h of x, and it's the integral from 2 to negative 3. If I go to h of x, the answer is going to be 6 from negative 3 to 2. So I'm definitely going to take 5, and I'm going to multiply that by the integral from, now it's negative 3 to 2, but using the property we learned, if you switch those boundaries, if you switch the order, you basically just change the sign. So instead of 6, I'm going to make it negative 6, and that'll give me negative 30. For the next one, we're going to go from negative 3 to 2, and that's going to be 6 times f of x. So using that constant rule, I'm just going to have 6, and f of x is 4, the integral, plus 2, and h of x from negative 3 to 2 is 6. And so then I would just evaluate and get, in this case, it's going to be 24 plus 12, which is 36. I then take the integral of this. Now, this is a more complicated function. It's got x squared, f of x squared, and it's times h of x. And there really isn't a property for multiplying functions, definitely not squaring them. But if you notice, the boundaries are the same. So no matter how complicated this function is, the answer will always be 0. Now we're going to go from 2 to negative 3 of h of x minus f of x. Well, I really don't have information from 2 to negative 3. I have information from negative 3 to 2. So what I'm going to do is I'm going to treat it as if it were negative 3 to 2, and then I'm going to just change the sign at the end. So for h of x, I have 6. For f of x, I have 4. So that gives me 2, but remember, we're going to switch the sign. So the answer is actually negative 2 because of that switch in boundaries. The last one, we're going to go negative 3 to 5. Now, I know the integral from negative 3 to 2 is 4. So this is going to be the additivity property. From negative 3 to 2 is 4. And then from 2 to 5 is negative 10. So I can add that negative 10 here, gives me negative 6. So I know the first piece is 4, the second piece is negative 10. If I combine them, I get everything from negative 3 to 5. And the last one is going to be the integral from 5 to 10. The integral from 5 to 10, I don't have a 5 to 10 here. I do have a negative 3 to 10, and that's supposed to be 7. But I really don't want to know I want to know from 5 to 10, not from negative 3 to 10. So something I can do, since I already know from negative 3 to 5, I know that chunk is negative 6. The whole chunk is 7. I can subtract this piece off of it. Make sure you subtract. So that's 7 minus negative 6. And the result should be the total from 5 to 10. Okay? So that's properties of integrals. That's some examples explained. In the worksheet that I gave you, you will see at the very bottom some practice problems related to this. Here's our areas under curves, and at the bottom you see here the setup where you're given some information and then you need to go ahead and use the properties to find the answer. Hope it goes well. We'll see you tomorrow. Bring this completed so we can get some feedback and peer grading. I look forward to it. Have a great one. Hope you enjoy your day off.